In up to the last video, I have shown some of the problem on comprehensive or descriptive linear equation. I will continue that with some more variety of linear equation, and then after I will come to the next subjects. Okay. So moving on to the number, it is maybe number 7. So it says two cars start at the same point and move in the same direction. Start at same point and moving towards same direction. Okay. One car travel 5 miles per hour faster. One car travel 5 miles per hour faster than the faster 5 kilometers faster than the twice of the other car. After 10 hours of travel, the distance separated the cars is 60 miles. Then you have to find what is the speed of the cars. Okay, so two cars moving in the same direction, starting from the same point, and one car traveling 5 miles per hour faster than the twice of the other car. So they are starting from the same point, okay, and same point and moving in the same direction. So direction also same, because this is important for any motion which is linear, because that will be and with the same speed or velocity. There is no change in velocity so then this is considered to be a vector. So vector is very important to have direction specified. If it is not in the same direction, then the sum will be of different kind. So as because it is said the same direction, let's say this is faster car C1, this is slower car C2. Now what is the relation between the C1 and C2? I am writing it side by side, then one by one I will put the condition. It is one car, let's say this one, the faster car, is moving 5 miles per hour faster, so it has to be added with 5 other car, because this will be faster, then this will be added to match up the speed. Now it is not only the 5, then that twice of the second car, the twice of second car, then plus 5 will equalize the speed. So this will be your first equation. So we can say C1 minus 2C2 equal to 5. So this will be your first equation. Second equation, after 10 hours of travel, the distance separated of the car is 60 miles. So the faster car will move more distance, let's say it is D1, and the slower car will move smaller distance, let's say D2. Okay, so as they are starting from the same time, so the difference between the car will be one end it is fixed, other end if it is end point we can separate, that will be the separation. So for first car, the distance D1 will be the speed into the time. This is the formula. because distance is nothing but the uniform velocity into the time. So this is the first d1, and or d2 is equal to c2 into 10, because the separation is counted after 10 hours. So 10 hours, whatever the speed they are having, they accordingly they will move. So as c1 is more, d1 has to be more. So d1 minus d2, this is said to be 60 as per the question. So d1 minus d2 is equal to nothing but c1 minus c2 whole into 10. I can take common because both are multiplied 10, is equal to 60. Now c1 minus c2 is equal to 6. This will be your second equation. So directly I am putting it here. c1 minus c2 is equal to 6. This will be your second equation. Now these are two equation of two variables c1 and c2. By any of the method that I have shown to solve the linear equation, elimination or your you can say separation, or what you can say that cross multiplication, or the some of the problem that I have solved graphical it may not be possible because it will be a longer process. Otherwise you can use the substitution method or elimination method. Elimination, you can eliminate any of these two by multiplying, or substitution you can put the value of one to others. So here I will it will be easier to eliminate the thing, because c1 is having factor of its multiplication of coefficient of 1. So these are equal. So directly if I minus, I put this one, so c1 will be cancelled out. Here I will get minus c2, here I will get minus 1. So minus will cancel out, c2 is 1. So as c2 is 1, c1 will be 6 plus 1, that is equal to 7. So this is mile per hour, and c2 is 1 mile per hour. So this is your requirement of the sum. So this can be solved. Okay. So this is the other kind of linear equation. Okay. So you have to understand that variable will not come always in the form of x and y, rather could be anything. So accordingly you have to solve. So further going to the problem 8, two people start out 100 meters apart. Two people start out 100 meters apart from each other. 100 meter apart from each other, and start moving towards each other at the same time, and start moving towards each other at same time. One person is moving at half the speed of the other person. One person moving with at half the speed of the other person, and they meet after 25 seconds of travel, and they meet after 25 seconds of travel time. Seconds of travel, you can say travel time or traveling something. What was the speed of each person? What was the speed of each person. Okay, so this is your, so two-person starts out 100 meter. Let's say this is person one, this is person two. They are moving. They are at 100 meter apart. This is 100 meter. Each other, and starts moving towards each other. He is moving this way. This is moving to, because both will move each other. That means they are facing each other. Same time. They are started at the same time. One person moving at half the speed of the other person. So P1, let's say, and P2 is the speed of. So this I am taking the same way. P1 is the speed of P1 and P2 is the speed of P2. One person and moving half the speed. So let's say P1 is slower, so it will move at the half of the speed of P2. It is moving faster, so it will travel more distance in same time. The other person, they meet after 25 seconds. So that means when they meet, it will travel lesser time. The distance d1, let's say this is distance d2. So they meet after. So d1 will be traveled in 25 seconds with the speed of p1, and d2 will travel 25 seconds with the speed of p2. So this will be the condition. And they meet at 25 seconds. What is the speed? So these are the equation. One is this one, and other was this one. So distance traverse is 100 meters. So in this case d1 plus d2 is equal to 100. So accordingly you can put this value. So from there I can get p1 plus p2 will be 4. If you put the d1 and d2 value, I will get p1. So here p1 is equal to half of p2. So you can either eliminate or substitute the values. So you will get p1 is equal to half of p2. So p2 is equal to 2p1. So 3p1 is equal to 4. So that means p1 is equal to 4 by 3. That is the speed of the unit is in meter per second. So it will be meter per second p1, and p2 is accordingly 2 of p1. That means 8 by 3 meter per second. Okay. So this is of similar kind, but it's some slightly different from the earlier one. And next, moving to the problem number 9. Two boats starts at the same time. Two boats start at same time. One boat starts travel to the east. One boat start travel to the east at 45 miles per hour. At 45 miles per hour, and 2 hours later the second boat starts traveling. 2 hours later the second boat starts traveling to the east at 60 mile per hour. 60 mile per hour. At same point in time, the faster boat will at same time, at some time, not same time, at some time, some point of, at some point, at some point in time, the faster boat will boat will be 145 miles in front of the slower boat, in front of the slower boat. How long has each boat been traveling when this happens? When this happens. So two boats starts at same time. One boat starts traveling to the east at 45. So your north, east, west, south. So one boat starts traveling to the east at 45 kilometer. One boat start traveling at 45. So this boat number 1 is 45 mile per hour. Okay, and 2 hours later the second boat starts traveling to the east. So after 2 hours another boat starts. The boat 2 starts with a 60 mile per hour. Okay, but it is starting, let's say this is traveling t, so then it will travel t minus 2, as because I'm considering time in hours, so it has started from after 2 hours. So it will, whatever thing we'll consider for boat 1, it has to be considered for t minus 2 hours. Okay, is at same point in time the faster boat will be at some point of time. So after traveling, as I assume t is unknown, after some point of time, let's say it has traveled t hours, the difference between their distance is 145 miles in front of the slower boat. So the faster boat is moved out further, so it has moved out further, and the distance it has traveled, as if being the distance more than 140, so it has crossed the slower boat and then further moved 145 away from this after certain time. So up to that position it has moved for t hours. So the distance it has traveled, it is 45 into t, and for this, so if it is the distance d2, so d2 would be 60 into t minus 2, because it has less traveled by 2 hours. So now in between the distance, the difference is 145. So we can put it in equation, the distance between d2, as because d2 is more, minus d1 is equal to 145, it is said. So d2 as per our our understanding, it will be 60 mile per hour and time is t minus 2, and whereas d1 will be 45 mile per hour and time will be t. Okay, so this will give 145. Now if you solve it, I will get some value. I will rub it. So 60t minus 120 minus 45t is equal to 145. So 60 minus this is 15t is equal to 120 will be that side, 265. So t is equal to how much? 15 I reduce it 15, 5, 5 is 5, 1, 5, 3 will be 17. So time traveled by the slower boat is t. So how long has each boat been traveling when this happens? So the first boat has traveled d1 is equal to, I have got the time t and the speed is 45. So 45 into 17 will be the answer. So 5, 8, 76. This much miles he has traveled, and the other one will travel how much? D2. D2 will be 60 into t minus 2, that means 15. We multiply, really 900. So this will be the distance traveled by respective boats. Okay, so this is, now move to the problem number 7, 8, 9, 10. One machine can complete a production run. One machine can complete a production run. A production run at a factory in 46 hours. Two machines can, I'm using the short form, I'm not writing the full machines spelling. Two machines can complete the production run in 25 hours if they work together. If they work together. Okay. How long would it take? How long would it take the second machine to complete? The second machine to complete the production run if it had to do the job by itself. So the problem says there are two machines, let's say machine 1 and machine 2. Okay, completes a production run. One machine, let's say machine 1 I'm talking about first, complete the production run at a factory in 46 hours. Okay, there are a lump of job that the machine 1 is completing at 46 hours, and two machines together, machine 1 and machine 2 together, can complete that same lump of job in 25 hours, sorry. 25 hours. So from there you have to find the machine 2's efficiency and at what time you can complete the job. If the total job has to be completed isolated way by the machine 2. So you can say if this is the lump of job, let's say I am taking it x number of job, x value of job. So this same x value of job is doing by M1 M2, that individual, if capabilities, let's say this is denoted by M1 and M2. So what is your M1? The rate at which he completes job per hour, we can say it. And same for M1 plus M2, the rate of job will be x by 25 together. So from there you can say that if I deduct M2, so the rate of job of M2 individually could be this one, means I am deducting the value. This is, let's say this is second equation, this is first equation. So the rate of job done by the machine 1 is total job by the number of hours taking to complete the job. So this will be the rate of job for M1 and this will be the rate of job both together. When the same job is completing into 24 hours, the rate of job for together they are getting. So if I deduct the M1's efficiency from both the efficiency together, so I definitely get M2's efficiency. So now this is the case. So I can say that M2, here I am writing it fairly, the equation comes M2's efficiency is nothing but the total efficiency minus M1 efficiency. So if this is the case, the time taken by M2 to complete X would be the total job by the rate of, this is M2's rate of doing job, that means X by 25 minus X by 46, total job by rate, because what I am getting, total job by total time is the rate. So if it is bring here, so total time will be the total job by rate of doing job, the same way. So now the equation says it is nothing but x upon x, I am taking common, so it will be 46 minus 25 will be in the denominator, and this 25 into 46, the LCM of the fraction that I am subtracting will come here. So x will not contribute anything here and x not equal to 0. The condition is that total job cannot be 0. So x I can eliminate. From there the equation, the ultimate the value will come is equal to 25 into 46 divided by, if I subtract, it will come 21. So now if I simplify it, how much it will come? It cannot be further reduced, so rather we can add it, you can multiply it, 155 115 divided by 21. So this is the M2's time, that means time taken to complete. So you can calculate further, or this much will be the time taken by the M2. You can also reduce by calculating. So I am not doing that, you can do yourself. So this will be the in hours, the time taken by M2 machine individually if he wants to complete the same lump of job that together and M1 individually done. Okay. Moving to 11. One person can can mount a field in 52 minutes. So even if not able to understand the exact literal meaning of that, but seeing the statement you can understand the person is something doing with the field in 52 minutes. Need not to understand this word specifically literally, rather you can have a look on the statement and you can understand the man is doing something as a whole to the field. Okay, minutes. And a second can mow the same field in 40 minutes. In 40 minutes. How long would it take? How long would it take the two of them to mow the field together? It is almost or just very much similar to the earlier problem that I have described. There are two persons that I am assuming that is person 1 and other person is person 2. The character is a 2 person, and the first person is doing everything in 52 minutes, and the second person is doing in 40 minutes. So whatever with the lump of job, the same thing I can assume. The lump of job, that means a field which is fixed of fixed size for both of the case, and if they are doing the whole field, so the job is fixed to them. So I can assume that job is X. So as the first person doing in 52 minutes, the rate of job the first person can do per hour is this one, and that's for second one can do this much rate. How long would the both together? So both if comes together, so their rate of doing job individual, because they are doing individually, not not serially, rather they are doing simultaneously. So their rate of job will be added when they are contributing together for any task. So task is X here. So total task by the rate of job doing this case, as because they are coming together, so it will be added. Okay, so as this is added, so the equation is the total time in saying TT I am saying is equal to the same. X will be cancelled out, the LCM of this will come on the numerator, and whatever the summation, it will be here. So 40 plus 52, that means 92. So you have to be very fast for this calculation. It should not take much time. Rather, if you ride your head or ride your mind properly, you can get the concept very easily. There is no big deal in that. I am not simplifying. I am not reducing to get the exact LCM. Rather, I am keeping both the terms together to get LCM. So minimum, it is always true for any number A and B. What would be the LCM? It is the multiplication of both of these two. This is the simplest one you can assume. So this I am using the same thing. I am not going to calculate the exact LCM for that. Okay. So this will be the case. So this will be 46, 26, further reducing 23, 13. So it will cannot be reduced further. Rather, the answer will come 520 by 23. So this way, this much you can say the hours it will take, both together will take time to complete, not hours, it is minute. Okay, as because the units are given in minutes. Okay, so the answer will be this. So moving to next. This is number 12, we can say. Number 12. One pump can fill a pool. One pump can fill a pool in 11 hours, and the second pump can empty the same pool, and second pump empty it in 4 hours. 4 hours. While pool is full, accidentally both the pumps starts and at same time, starts at same time. So how long will does it take to empty the pool? So this is the condition. There are one pool, one is filling the pool, one can empty the pool. The pump which is filling is taking 11 hours, so one which is emptying taking 4 hours. So this is pump 1, this is pump 2. Okay, so I can say this is the total pool of X quantity, X capacity. So the pump 1 efficiency is X by 11 and pump 2 efficiency is X by 4. So when both works together, here you can understand, say both together not for the same purpose. Whether they are filling or emptying, then purpose will be same. So when the purpose defeats each other, then the efficiency will be comes as a subtraction function. When the effort are given for a same purpose, then efficiency will be added. That you must understand. So one is filling, one is emptying. So their function is contradictory. So their efficiency must not be added. So now whether this is higher or this is higher, by seeing the denominator you can say this is higher. So efficiency from the bigger has to be deducted, the smaller one to be deducted from the bigger. So your equation must stay like this. So the overall efficiency for this work, because anyhow if the pump is there which is faster to empty, so definitely after some time it will be emptied. So the efficiency for emptying the pool will be this one. So the total function is X, and your efficiency under this, the time taken will be total job by the overall efficiency or overall work done per unit time. So if I solve this will nothing but the total time taken, it will be then again LCM will be on the top, and 11 minus 7 and 4 is equal to 7. So that is equal to 44 by 7 will be the time taken to empty the sump. Okay, so this for now. I will move on to a different kind of problem in the later video, that would be on the inequation. Till now I have seen equation, that means there would be a fixed solution, one solution if it is a linear equation. But there may be some equation that is not exact the equation in equation. That means it will be satisfied for a set of values, not a single value. Okay, so this kind of problem I will also explain in the next video. Thank you for now.